The ability to travel through time, whether it is to fix a mistake in the past or gain insight into the future, has long been embraced by science fiction and debated by theoretical physicists. While the debate continues over whether traveling into the past is possible, physicists have determined that traveling to the future most certainly is. And you don't need a wormhole or a DeLorean to do it. Real-life time travel occurs through time dilation, a property of Einstein's special relativity. Einstein was the first to realize that time is not constant, as previously believed, but instead slows down as you move faster through space. As part of his theory, Einstein re-envisioned space itself. He coined the phrase, space-time, fusing the three dimensions of space and one dimension of time into a single term. Instead of treating space as a flat and rigid place that holds all the objects in the universe, Einstein thought of it as curved and malleable, able to form gravitational dips around masses that pull other objects in, just as a bowling ball placed in the center of a trampoline would cause any smaller object placed on the trampoline to slide towards the center. The closer an object gets to the center of the dip, the faster it accelerates. The center of the Earth's gravitational dip is located at the Earth's core, where gravitational acceleration is strongest. According to Einstein's theory, because time moves more slowly as you move faster through space, the closer an object is to the center of the Earth, the slower time moves for that object. This effect can be seen in GPS satellites, which orbit 20,200 kilometers above the Earth's surface. These satellites have highly precise clocks on board that gain an average of 38 microseconds per day due to time dilation. While this time gain seems insignificant, GPS satellites rely on their onboard clocks to maintain precise global positioning. Running 38 microseconds fast would result in a positioning error of nearly 10 kilometers, an error that would increase daily if the time difference were not constantly corrected. A more dramatic example of time dilation can be seen in the movie Interstellar when Matthew McConaughey and his crew land on a planet with an extreme gravitational field caused by a nearby black hole. Because of the black hole's intense gravitational influence, time slows dramatically for the crew on the planet, making 1 hour on the surface equal to 7 years on Earth. This is why, when the crew returns to Earth, Matthew McConaughey's daughter is an old woman while he appears to be the same age as when he left. So why hasn't humanity succeeded in making such drastic leaps forward in time? The answer to this question comes down to velocity. In order for humanity to send a traveler years into the future, we would either have to take advantage of the intense gravitational acceleration caused by black holes or send the traveler rocketing into space at close to the speed of light, about 1 billion km/h. With our current technology, jumping a few microseconds into the future is all humans can manage. But if technology one day allows us to send a human into the future by traveling close to the speed of light, would there be any way for the traveler to use time dilation to return to the past and report her findings? Interstellar travel reaching close to the speed of light might be possible, says Dr. Jamie Matthews, professor of astrophysics at the University of British Columbia. But this voyage is one way, into the future, not back to the past. If we can't use time dilation to return to the past, does this mean that the past is forever inaccessible? Perhaps not. Einstein proposed that time travel into the past could be achieved through an Einstein-Rosen bridge, a type of wormhole. Wormholes are theoretical areas of spacetime that are warped in a way that connects two distant points in space. Einstein's equation suggested that this bridge in space could hypothetically connect 2 points in time instead if it were stable enough. At the moment, even an Einstein-Rosen bridge cannot be used to go back in the past because it doesn't live long enough. It is not stable, Matthews explains. Even if it was stable, it requires other physics, which we don't have. Hypothetical particles and states of matter that have exotic, physical properties that would violate known laws of physics, such as a particle having a negative mass. That is why wormholes are only science fiction. While it would be fascinating to travel back in time to see the dinosaurs or to meet Albert Einstein and show him the reality of time travel, perhaps it is best if the past remains untouched. Traveling to the past invites the possibility of making an alteration that could destroy the future. For example, in Back to the Future, Marty McFly travels to the past and inadvertently prevents his parents from meeting each other, nearly preventing his own existence. But if he had undone his own existence, how could he have traveled back in time in the first place? Marty's adventures are a variation of the grandfather paradox. What happens if you go back in time and kill your grandfather before your father is conceived? If you are successful, how is it possible that you're alive to kill your grandfather in the first place? A recent study at the University of Queensland may have the answer to this baffling paradox. In this study, the researchers prove mathematically that paradox-free time travel is possible, showing that the universe will self-correct to avoid inconsistencies. If this is true, then even if we could travel back in time, we would never be able to alter events to create a different future. While these new findings are enlightening, there appears to be more evidence that, although time dilation can allow us to glimpse the future, we will never be able to visit the past. As the late Stephen Hawking said in his book Black Holes and Baby Universes, the best evidence we have that time travel into the past is not possible, and never will be, is that we have not been invaded by hordes of tourists from the future.